In this demo, we will use the TM102 I2C digital temperature sensor from SparkFun. This sensor will connect to the Raspberry Pi using the available I2C bus. We will demonstrate how to work with the I2C bus, find available sensors, and take measurements. The first step, of course, is to connect your I2C sensor. You will see here on the bottom of the screen, this is the sensor pinout for the TM102 temperature sensor. The important part of this diagram is the JP1 jumper, which is the available pins that we have to connect to the Raspberry Pi. On the upper right-hand side, you will see a diagram showing the Raspberry Pi pinout and the labeling. In blue, you will see the boxes that represent the I2C lines. What we need to do is connect the SDA to the GPI 02 pin, the SCL to GPI 03, and then the power and ground to the associated ground and power on the I2C header pins that come out of the Raspberry Pi. Please do note, be careful in connecting to the correct power supply. You will also have a 5-volt power supply available on the Raspberry Pi, but for this sensor and for many sensors, 3.3 volts is the maximum. Okay, if you've connected it correctly, it should look something like this. You can see the sensor and you can see the various wires connected to the Raspberry Pi. Okay, so let's jump into MATLAB. So what we need to do is establish a connection to our Raspberry Pi. So we do that by typing mypi equals raspi. And MATLAB will return showing that there is a connection, and it'll also show that there are available I2C buses. Now what we'd really like to know is for the I2C sensor that we've hooked up, what is the address that it sits at? So there's a function provided by the MATLAB support package called scan I2C bus. So what we'll do is we'll type scan I2C bus, and we pass it mypi, which is the object representing our Raspberry Pi, and we pass it I2C-1, which is the particular I2C bus that we'll be connecting to. We do that, and it'll actually show you that it sees a sensor at address hex 48. So we'll be using that to establish our connection to the sensor. So the next step will be to create a variable for the temperature sensor itself. Well, let's call it temp sensor. And then we create an I2C device object, let's call it, and we use the function I2C dev to do that. And all we need to do is pass it the Raspberry Pi and the address, as well as the bus that we're using. So we do that, we press return, and you can see now we've created an I2C device object with, on that particular bus, I2C-1, with the address of hex 48. Okay, now what I'm going to do is I want to read the temperature. So I'm going to open up one line of code that I've written here called readtemp102. I'll open that up in the editor, and I'm going to run that, and basically you call it the secret sauce here, is in this particular function. This comes from the data sheet of the temperature sensor. It tells us how to interpret the value that is presented by the sensor on the I2C bus, and it does the conversion for us and converts it into degrees Celsius in this case. So if I run that, and looking back in the MATLAB workspace here, it shows me that the temperature is 25.875 degrees. I can run that again using the up arrow. I can repeat the previous command, and you'll see it's still 25.875 degrees. I can hold on to it and see if I can warm it up, and then it's warmed up a little bit. So that's great. So now we can easily get in the data from the temperature sensor, but we probably want to do something additional with it. Why don't we plot the data? So I'm going to open up a second function that I've written, or a script here called livetemp2 for temp102. And what this does is uses the plot function, provides some labeling for the axes, and in a loop takes 1,000 readings from this temperature sensor and does that conversion that we just talked about. So let's run that, run livetemp2, and you can see that the temperature is about 26 degrees. I'm going to hold on to it, and then you can see it warms up a little bit. Got it up to 27, 28, almost 28. Let go, and it starts to drop again. So in just a few lines of code, we are able to plot the live temperature reading that's coming in from our Raspberry Pi through this I2C sensor. So to summarize, we just demonstrated how you can connect a digital I2C sensor to your Raspberry Pi. You can easily convert the data and you can plot the temperature as you acquire it. We demonstrated this for a temperature sensor, but the workflow is similar for any I2C sensor. In the next demo, we will show you how to work with another common type of sensor, a 3-axis accelerometer.